Pre-cal. Test is Thursday. We do not have block day this week. Okay, so I will see you Wednesday and Thursday. Good news is there's 2 days to review. Today's the last day of new stuff. Review, test, and then catch-up day. So life is good this week, I think, for you guys.
That sounds like an opinion.
It is an opinion. All right. Questions from worksheet 4. 1 through 42 all. Crystal, you were concerned with the ones and negative ones down here? Okay. Let's do some of those, because maybe we didn't do any or many of those. Inverse sine of 1. Remember what that means is, that means find an angle whose sine is 1. Now, we don't really need to rewrite all that, but that's what it means. Find an angle whose sine is 1. Let's see.
That's pi or 2. Or no, that's.
No, yes, you were right the first time.
Oh, it's negative. Yeah, pi.
Sine is equal to 1 up there, right? Because sine's the y coordinate. Right?
Yes.
And Tyler, trust yourself. What angle is that?
Pi over 2.
Pi over 2.
I totally just didn't finish the rest of my
Rest of your thoughts?
Mm-hmm.
Arc cosine of 1 means find an angle whose cosine is 1.
0.
And cosine is equal to 1 over there on the right, because cosine's a left-right x thing. So its maximum is over there at 0. Arc sine negative 1. Ooh, let's do that one. Good. It's in the down spot, but is that negative pi over 2 or 3 pi over 2?
Yeah.
Why negative pi over 2? Not shortest answer possible. And 3 pi over 2 would mean you went through the black hole, the quadrant of death, and you died.
Yeah.
It's a little dark for Monday morning, but stay out of the third quadrant. Olivia?
Can you do 16?
Yes.
Sounds like something else.
Inverse tangent of negative square root of 3. So find an angle whose tangent is negative square root of 3. Tangent is negative in the second and fourth. Quadrant 2 versus quadrant 4. And root 3, there's the tangent 3 trick. If there's 1 3 in the tangent, there's 1 3 in the angle. So I know it's over 3. And then over 3 in the second or fourth, that would be the steep angles. So which one do I pick?
Probably that one.
Yeah, that helps.
Quadrant 2 or quadrant 4?
4.
4, the quickest way there. So negative pi over 3.
So if it's the root or square root.
The tangent trick, is that what you're trying to get at?
Yeah.
The tangent of pi over 3 is square root of 3.
Okay, so anytime it's going to be.
Uh-oh.
Just testing you.
Tangent of pi over 6 is root 3 over 3. Again, it's like the tangent 3 trick.
Anytime there's a tangent with a thing.
If there's a 3 involved, there's 1 3 involved. If there's 2 3's involved, then it's a 6. Or the other way, if it's tangent of pi over 6, there's 2 3's involved. And after that, the quadrants can help you figure out the plus or the minus. So if you choose to memorize that, that's a little quicker than doing the sine over cosine. And it's not too hard to memorize.
15.
Could you do 26?
15 and 26. 15, arc tangent negative 1. Let's see. Tangent is negative in quadrant 2 and 4. We just kind of did this part of this problem. We've got to be in quadrant 4. The other way to know that is tangent always comes from 1 or 4. So where is y over x? Where is sine over cosine equal to each other? Well, halfway. I'll buy that.
Root 2 over 2.
Well, sine and cosine are root 2 over 2. What's the angle there?
45.
What's the angle in radians there? Negative pi over 4. So you said a lot of good things. Root 2 over 2, 45 degrees.
I did, just not for that.
Sort of, but you didn't answer the question. What angle has a tangent of negative 1? Negative pi over 4.
Gotcha.
And then 26.
Picture said 26.
Yeah.
Secant. Inverse secant. I don't want to do inverse secant.
Cosine.
So let's do inverse cosine. And what price do you have to pay if you're switching from secant to cosine?
Put it, go.
You got to flip it. So
Here.
small price to pay for a big benefit. That's well worth it.
Write it down.
Let's see. Cosine has to come from first or second quadrant. Cosine's positive in the first quadrant. Cosine is equal to 1/2.
It's probably going to be there.
So is it over 3 or over 6? I know it's not over 4. That's root 2 over 2. Let's see. Cosine is the x-coordinate. So I want the x-coordinate to be short and the y-coordinate to be long. So pi over 3. Cosecant. Oh, similar problem. I don't want to do a cosecant problem. I'll do 32. I just don't want to work it as a cosecant problem.
That's negative sine.
Inverse sine of 1/2. So where would the sine equal 1/2? So the y-coordinate is the short side. So yeah, pi over 6. Unit circle, unit circle, unit circle. And then more unit circle.
Number
Which one?
4.
Number 4. Arc cosine of negative 1/2. Let's see. Cosine's got to come from 1 or 2. So I know I'm in the second quadrant. It's negative. We just did a cosine 1/2 problem. Cosine equals 1/2 at the over 3 mark. So what's over 3 in the second quadrant?
So it's root 3 over 3.
No roots involved. I want to know what angle is the steep angle in the second quadrant. 2 pi over 3. Yes. So this 35 and 36 come from teachers who teach it a little bit differently than I did. So let's see if we can still figure this out. Highlight the part of the graph of y equals sine of x where we will restrict the domain for y equals inverse sine of x. Let's see. Inverse sine was restricted to negative pi over 2 to pi over 2. So what it's talking about is only highlight the graph from negative pi over 2 to pi over 2. That's what that question means. 36, similar question. Inverse cosine. Well, cosine is 0 to inverse cosine is 0 to pi. So we highlight from 0 to pi. So it's different. So some people teach it from the graph rather than teaching it sort of from the unit circle. It's just a different way to do it. All right. I didn't mind spending a whole bunch of time on those because what we're going to do today is built on that knowledge. So if you're good with that, today isn't too much harder. I feel like I could say that every day in math. If you understand everything up to today, then today won't be bad.